Hello, everyone. Good morning, good afternoon, good evening, depending upon where you are joining from. Thank you so much for taking your valid time for attending Festive Tech Calendar 2021. Myself, I'm Deepthi Goguri. First of all, I would like to thank Gregor Sati and Richard for giving me this wonderful opportunity to be part of Festive Tech Calendar 2021. Today, I'm going to present on the topic Query Store on Prem and on Azure. Before beginning my session, I would like to wish each and every one of you Merry Christmas and Happy Holidays. A little bit about me. I'm a database administrator with several years of experience in managing SQL Server and databases, and I'm a Microsoft certified trainer and Microsoft certified solution expert. I did my master's in computer technology at Eastern Illinois University, and uh, I am an organizer for Diversity, Equity, and Inclusion User Group, and also South Florida AI and Microsoft Data User Group as well. And also, I do volunteer for Women in Technology group as well. Apart from my job and then community work, I love arts and crafts, and I do blog for dbnuggets.com. That's my website. And if you'd like to contact me, at dbnuggets is my user ID, and Deepthi Goguri is my name, where you can search on LinkedIn and you can contact me. It would be an honor to contact you. So, what are we going to cover in this session today? We are going to talk about the introduction of the query store. Like if you are not familiar with this feature, this session will give you a fairly nice idea about what is query store and what are the benefits of the query store. And also uh, in one of the benefits is the plan forcing, how to plan force one of the execution plans and how to unforce them. And when you force the plan, you might also see some of the failures and how to handle those failures. And we are also going to talk about the automatic plan correction, where you do not do anything from your side, but once you enable the automatic plan correction feature, it will go ahead and automatically force the plans for you. So we are also going to see that in our demo as well. So let's talk a little bit of introduction about Query Store. What is Query Store? Query Store feature has been introduced in SQL Server 2016. Basically, what it does is it will go ahead and capture all of your queries along with the query text, query plans, query ID, and all the other resource consumption information over time so that you can go ahead and look into the plan regressions if you have any, or why plan has been changing. And if you also find one of the query plans is working very fine, taking less amount of resources, you can go ahead and force that plan. That is one of the benefits of query store. And uh, uh, and it it will give you an option to choose the optimal plan, like I said, by forcing the plan. And if you have a SQL Server, this query store feature is not automatically enabled because it is not a server level feature. It is a database level feature. You need to manually go ahead and enable the query store. Where if you wanted to collect the information on that particular database, you can go ahead and enable query store on that database. And this particular query store feature is disabled by default on SQL Server and Azure Synapse Analytical Database. So if you want to enable, you need to manually go ahead and enable on each of these databases. And it is enabled by default if you are on Azure SQL Database. And you cannot enable it on master or TempDB database. And the data that is captured on the query store will be captured inside the primary data file of the database. So let's talk about how query store actually work. So this diagram, right, how it actually works looks a little bit complicated, but let me explain in a simple words. Whenever the query runs on the SQL server, it will first go ahead and check whether it is running for the first time. So if it is running for the first time, then it will go ahead through the compilation, the optimization phases and create the execution plan for that query. But if the query is not running for the first time, then it will go ahead and check if the plan is already in the cache. If the plan is not in the cache, it will go ahead and compile and optimize and create an execution plan for that particular query again. But if there is an execution plan already there in the cache, it will go ahead and use the same execution plan further. But before going further, it will go ahead and check for the recompilation of the query. So, for example, it will go ahead and check if the plan that is already in the cache, right? If the plan that is already in the cache, is it same as a force plan? Let's say we took a query, we executed a query which we already forced, and we are using a force plan. It will go ahead and check the plan that has been taken from the plan cache. Is it similar to the force plan? For example, if it is not similar, right, it is completely new, it is completely different, then it will go ahead and go through the optimization and the compilation, and it will apply the force plan. It will create the same exact copy of the force plan. If the plan is similar to the force plan, it will go ahead and proceed further. Before executing the query, the query text and the query plan information will be captured inside the plan store, which is in memory. It will go ahead and save that information in memory asynchronously. Then, once the query is executed, that executed information, the runtime stats information, will be stored inside the runtime stat store, which is also in memory. It will store that information asynchronously. Later, once the flushout interval has been reached, which we are going to talk about in the coming slides, once that interval has been reached, all of this collected information in memory, the runtime stats information, will be flushed out to the disk into the query store schema. This information will also stored inside the query store schema asynchronously. But you might have a question, but why do we need to have a query store when we already have plan cache? All the plans that are created will be saved inside the plan cache. But what is the difference and what are the advantages to enable the query store? Plan cache, like the plans will be saved inside the plan cache, but whenever you restart the SQL Server, all of these saved plans will be flushed out, and it will get once your SQL Server restarts, all of this plan cache will be flushed out. But in the query store, as it collects the history of the information, and as the data will be saved inside the primary data file, and it will stored inside the disk of the database, it will only flush out the old data once the cleanup policy has been reached. But it will save all the history of the information, and it doesn't affect once you restart the SQL Server. All the data is still there inside the query store. Plan cache will save the latest plans, but query store will collect the information, collect the plans over time. And if there is a memory pressure, right, the plans will be evicted out of the out of that plan cache. But in the query store, it will capture the information and it will only flush out all the information that it has collected in memory to disk once it reaches the flush out intervals. And if you use the plan cache, it is very difficult to know why the plan has been changed, and it is very difficult to identify the regression problems. By using the query store, it is easy to identify the problems and uh, solve the performance problems very quickly. What type of data is collected by using the query store? In SQL Server 2017 and above, it includes the weight stats information. So in SQL Server 2016, the weight stats information was not collected. Um, and it also collects the query text, query plan, query ID, CPU, IO memory, and all the other information which has been showing here: duration, logical reads, writes, physical reads, CLR time, DOP, and also the temp DB information, the temp DB memory used, row count, log memory used. All of this information will be captured. So it is very easy to identify the regression and also compare the plans because we all have all of this information being collected. So it will also collect the history of the plans, and it will also collect the top resource consuming queries. It is very easy to pull out the top resource consuming query so that you can work on optimizing those queries as well. So what are the query store operation modes? There are three query store operation modes. One is read only, which will only read the force plan information, and read write will also read the force plan information as well as write into the query store whenever it creates a new execution plan and collects the runtime stats information. Once you turn it off, it will not capture any of the information. The query store will be turned off. Excuse me. So the query store capture modes. There are four query store capture modes. All it will capture all of the queries, even the not important, not so important queries that you don't bother about. Even those kind of queries are captured. Auto is a recommended mode. Um, the auto is actually it collects the queries based upon how many times the query has run, and what is the compile CPU time. Based upon that, it will go ahead and capture that particular algorithm. How it captures the auto mode, we are not familiar about it. Microsoft has decided that for us. None means it will not capture anything. Custom meaning you can go ahead and customize those capture policies. Let's talk about some of the query store options. We are not talking about each and every option here, but we are going to talk about that in our demo. Cleanup policy is 30 days by default, meaning it will save the data within the query store for 30 days, and later, once the cleanup policy has been hit, it will go ahead and delete all the old data. Data flush interval is in seconds, meaning it will collect all the data in the memory for 15 minutes, which is by default. And once it has been collected, it will flush out that data to the disk, to the query store schema. You can change that definitely. Max storage size limit in MB is 100 MB by default for SQL Server 2016 and 2017, but it is 1 GB for 2019. You can definitely go ahead and change these default settings as well. For the complete list of settings, please follow this Microsoft Docs down below. So what are the query store benefits? There are several benefits. Let's go ahead and talk about them. It is easy to identify the regressions that are caused by your queries. If there is a query that is being that is creating many execution plans, and um, it is easy to identify why the plan has been changed, what might be the reason, what are the resource consumption, and you can go ahead and compare the plans side by side to go ahead and force a plan which you think might be optimal, so that the next time the query runs, no matter which is independent of the parameter value, it will go ahead and use the force plan that you choose, and it is very quickly to fix the non-optimal plan usage, because now you have the ability to go ahead and force a plan. You do not have to change any underlying code of that stored procedure or underlying code itself. You can just go ahead and quickly, with few clicks, go ahead and quickly force a plan until you completely solve the issue. It might take some time for the developers to go ahead and fix the issue within that store procedure by changing the code. So this is a quick fix to solve the problems until you completely solve the problem, by changing the code, underlying code. And there are some usage scenarios. I personally use the query store feature for the database upgrades. So we used to capture the baselines once we upgraded the database to the newer version of SQL Server. So we have done several database upgrades from SQL Server 2012 to 2016 and plus. Once we upgrade the database, we capture all the baselines by placing the database still in the older compatibility mode. Once we once we capture all of the query store query information by enabling the query store on the older compatibility mode. We will then go ahead and turn on the latest compatibility mode so that we can easily identify the changes that are being caused by the new compatibility mode. So if we find the older plan that has been used is running fine, we can go ahead and force a plan. But if we do not collect that information after changing and after upgrading the database, by placing the database in the older compatibility mode, if we do not do that, it is very difficult to know if the plan has changed or if the plan is same, uh, why the plan is being running so slow after the compatibility change. So it is very easy to identify that, and then um, force the plans based upon your workload and um, based upon your preferences. There are three stores in the query store. A plan store, obviously, it will store the query plans, query text, query ID information. Runtime stat store will collect all the runtime stats information, aggregated runtime stats information. Wait stat store will store the wait stats information. It will put the wait stats in different categories and it will store them. One of the query store benefits is the plan forcing. So let's go ahead and talk about the plan forcing. Just like the use plan query hint, we can go ahead and force a plan such that the next time the query executes, even if the plan is not there in the plan cache, it will go ahead and create a plan similar to the forced plan. Once you force the plan, we it is very important we monitor it, because sometimes some changes might cause your queries to create a new plan, and sometimes there might be some failures based upon if you do some of the operations like um, dropping the indexes or modifying the indexes which are being used by the force plan. If you drop the underneath the objects that you are using inside the force plan, it might cause some failures, so you can capture those failures as well. So you can force a plan by using graphical user interface as well as by using the T-SQL code. Uh, so by using the transact SQL, you can use SP query store force plan, and to unforce the plan, you can use SP query store unforce plan. Let's talk about the failures. As I told you, once you force a plan, there might be a couple of reasons why you might see the failures. Um, Failures meaning it doesn't fail the query, but it will capture the failure information within the query store. The objects that are being used within the query store force plan, like the indexes, if you drop or modify the indexes, you might see some of the failures like no plan, no index failure reasons. Um, so the query itself doesn't fail, like if the user executes that, even though there is a failure behind the scenes within that particular force plan, and it will go ahead and create a new execution plan like a normal like an the optimizer will go ahead and uh, recompile, and then it will go ahead and create a new execution plan like a normal form, but it will save those values like why it has created the new execution plan within the query store. We can see that, and we are going to talk about that in our demo. So how to monitor these failures? By using the graphical user interface as well as by using the T-SQL code. These are the by using the graphical user interface, you can view the failures by using queries with force plan um, under the query store folder within the database that you have enabled the query store, or you can run the catalog views. Um, Below is a query that has been captured from the Microsoft Docs down below. So let's talk about all of these slides first and then go to the demo part and then look into all of the demo one by one. Let's talk about the automatic plan correction. Automatic plan correction feature is enabled from SQL Server 2017 and above. So what it does is, it is like a You do not have to do anything once you enable the automatic plan correction. It is an automatically it is an automatic thing where it will go ahead and continuously monitor the regression in between the queries, and it will go ahead and force the last good plan. Let's say you have a query, and you have enabled the automatic plan correction, and automatic plan correction has forced a plan. And the next time it will go ahead and not only after forcing the plan, it will not stop there. It will go ahead and continuously monitor and watch for any new execution plans that are being created for that query. If there is a plan that got created for any reason, it will go ahead and compare that new plan to the already forced, ex, uh, currently forced execution plan. And if it feels the new execution plan is working better, it will go ahead and force the new plan. If it thinks if it is the old plan is doing the better job, it will go ahead and keep that plan as is without making any modification. And this process is going to happen continuously. And to enable automatic plan correction, which is only for the enterprise edition of SQL Server, you can, as well as it is enabled in Azure SQL Database as well. It will go ahead and you have to go ahead and alter the database, give the database name, set automatic tuning, force large good plan is equal to on, which will turn on the automatic plan correction. And you can see why the plan has been changed. Um, you can see that by using sysdmdb tuning recommendations. If you do not have you can run this sysdmdb tuning recommendation on any edition of SQL Server, but if you only turn it on, automatic plan correction, then you can see the results of it. You can also enable the automatic plan correction um, by using the Azure portal, by enabling the force plan underneath the automatic tuning, um, under your Azure SQL database, under the automatic tuning. Once you click on that, it will open up a plate where you can go ahead and force a plan, turn it on. Let's talk a little bit of query store hint feature, which is in the preview mode. So, let's say you have a query, and you have a parameter sensitive query where with one parameter might be very sensitive. It can only create 325 rows or something like that. And if you run the same store procedure with a different parameter, it will create a million rows. Now you might be like, the first time that you execute the store procedure, it might create a clustered index scan on that particular store procedure. And the next time you run the same store procedure with a different parameter, we might not need it to run with a clustered index scan, because we get only couple of 10 or 12 records. What will you do in that situation? If you do not have a query store, you'll go ahead and use the hints, like query hints, right? You'll go ahead and recompile that particular store procedure. But to do the recompile, you need to go ahead and modify the store procedure query text. But instead of that, if you use this query store, if you enable the query store, you can go ahead and use the query store hints without changing the underlying code. So for that, there is particular store procedure, especially for the query store. All you need is a query ID that you wanted to change, you want to recompile. You will find that query ID, and then inside the store procedure, which you are going to use for this query store hint, you need to just provide the query ID and what kind of query store hint you want to use, so that the next time the store procedure runs, like for example, you wanted to use the query store hint recompile, the next time that particular query ID runs, it will go ahead and recompile automatically. It will go ahead and monitor that particular store procedure. And not only the recompile, you can also use the max stop, recompile, maximum memory, minimum memory grant size, compatibility level, such kind of query store hints. So um, based upon query specific needs of your query, you can use the query store hints. This is a two-step process. The first step is to find the query ID. query ID by searching on the query text. Once you find the query ID, then you'll place by using the store procedure SP query store set hints. You will provide that query ID as well as what kind of option you want to choose. For example, here we are using the query store set hints on query ID 5, and we are using option recompile. So the next time that particular query runs, it will go ahead and recompile that. So based upon the needs, based upon if it is a parameter sensitive query, it will go ahead and automatically recompile and create an execution plan based upon your parameter value. Let's go ahead and see the demo now. So here in our demo, we are using AdventureWorks database, and so we are using AdventureWorks database, and let me see here. So we are using AdventureWorks database here. I would like to go ahead and turn on my query store to be turned on with the operation mode read write. So it will read as well as write the information. Let me go ahead and alter the database now, and then I would like to run some couple of the settings here, query store options here, but do not run this as it is because this is just my demo. I might be putting some of the values more. For example, here maximum plan square query is 1000. We do not need 1000, so let's change that to 100. So just for our demo purposes, I have provided that. So let's talk about these um, query store options here. We have already discussed some of them in our slides, but let's talk about them again. So operation mode is read write, is it can read as well as write that query store information. The threshold, the cleanup policy, right? The cleanup policy stale query threshold days is 30, meaning it will save the data for the 30 days. And once the cleanup policy threshold, which is 30 days, has been hit, once it hits the 30 days, it will go ahead and clean up the old data. Data flush interval in seconds is 3000, which is again once it collects the data in the memory, it will capture that information and flush out to disk for every 15 minutes, right? 3000 minutes here, 3000 seconds here. And maximum storage size in MB is 500, which is for default, it is for SQL Server 2016 and 2017, but um, for 2019, it's 1 GB. You can definitely change that according to your needs. And interval length in minutes is 15 minutes. For every 15 minutes, a new interval will be created, meaning that let's say a query will be running 100 times in that particular 15 minutes. No matter how many times the query runs within that 15 minutes, it will only have one row within that query store for that particular interval. It will aggregate the information, runtime stats information, and it will save it in the query store. The next time the interval has been changed, for every 15 minutes, the interval will be changed. So let's say the first interval is number one and the second interval is number two. In that second interval, no matter how many times the query runs again, it will only have one row in the query store with the aggregated information. Size Blaze cleanup mode is auto. This is a recommended mode because once you turn it on for the auto, once the size of the data, once the storage size of the query store reaches 90%, it will go ahead and automatically delete data until it reaches 80%. So with this, once you place this cleanup mode as auto, it will not change back to read-only mode. So, for example, if you turn this option size-based cleanup mode as off, then what will happen once it reaches the maximum size limit, which is 500 MB here, it will go ahead and change the operation mode of the query store from read write to read only because it cannot capture any more information because the storage size limit has been reached. So size based cleanup mode, we need to put this as auto, which is recommended, which will make sure the query store doesn't go to the read-only mode. And query store capture mode is auto. Again, this is a recommended mode. Max plans per query. How many plans do you want per query? I put it as 100, but 100 may be too much for some of the workloads for you because so many plans might be running at the same time. So you need to make sure you're choosing these options once you know what and how we can use them. Wait stats capture mode is turned on because I wanted to also capture the wait stats information. Let me go ahead and set these options. And once you have set the query store options, you can see those query store options by using sys database query store options. Once you execute that, you can go ahead and see what all options are there. Actual state in the actual state is read write, desired state is read write, and what is the maximum storage size that I have choose, and interval length in minutes, and what is the threshold dates, which is cleanup policy, and all the other settings that we have chosen. Now let me go ahead and clear out my query store and then clear out my procedure cache because I wanted to capture the information freshly. So let's run couple of the store procedures, just random store procedures, and see how it has actually captured that information. So once expand the database, and AdventureWorks is a database. So once you expand it, once you enable the query store, your query store folder is enabled. Expand that and right click on top resource consuming queries. You can see it in a graphical user interface, but you can also see the query clearly. Here you can see the query by hovering your mouse, but you can also see them in this way by clicking on the grid view. So here we executed two queries, the query ID 1 and query ID 2. Those are two different store procedures. They have created the plans as well. So these are the plans that this particular query has created. Now, um, let me go ahead and see if there is anything that has been saved inside the procedure cache. Definitely, it will save all of this information, the procedure cache information that has been executed. Now, let me go ahead and clear out my procedure cache. So if I clear out my procedure cache, will that also clear my query store? Let's see that by clearing out the procedure cache. So once I cleared out the procedure cache, I should not see any of these procedures. These are the create procedure. Let me clear that out, or we can also clear this out, clear procedure cache. I have cleared out everything. Now, let me go ahead and execute the query store if there is anything in the query store. If you see, the two store procedures that we have executed are still available in the query store. So this is like um, as the data is being saved inside the primary data file, all of the information will be saved here. So let me go ahead and clear out my query store. And let me go ahead and run some of the ad hoc queries. So we have to also talk about ad hoc queries. As query store will capture the information of the queries, what will happen if we have more and more ad hoc queries? Let's go ahead and run these queries. Let me refresh this. Once I refresh it, so there are two query IDs, right? We have run first one two times and the second one two times. So these two are the exact same queries, ad hoc queries, with a different IDs. So they have been treated as two different query IDs. Now what I will do is I'll run the same exact query with a simple space here. I put an additional space over here. So in the ad hoc queries, even if you have a single space, or if you change any query text of your comments, anything might change and create a new query ID. So once I execute that and go ahead and refresh the query store, it will go ahead and create a new query ID. So just one query with different parameters or a little bit of change in their query text has created three different query IDs. If you have more and more queries which are running like an ad hoc queries, it might blow up your query store very quickly. So it is always suggestible to create the store procedures. So let's put the same query that have been executed into a store procedure. Now let's go ahead and use that use that particular store procedure. Let me also clear up my cache and then clean up my query store. And then I execute this newly created store procedure twice with two different values. Now let's go ahead and refresh. Now, as it is a store procedure, we have just one query ID. No matter how many parameters we use, it only have one query ID. But if you observe here, it has created two different store procedures. The plan ID 1 is a first executed one, and the plan ID 2 is a newly created one. So if you hover your mouse over here and see the details of it, the total duration in time is 5 milliseconds. But if you see the new ones, if you hover your mouse, it is about 1446 milliseconds. So it is taking a lot of time over here. So I wanted to go ahead and force plan ID 1, right? To force a plan ID 1, just go ahead and click on the plan ID and then click on the force plan. Once you click on the force plan, it will say, do you want to force a plan 1 for the query 1? Let's say yes, which will give you a little tick mark over here, which says that this particular plan ID is currently forced. Now, the next time I would like to go ahead and execute this particular plan ID, right? You can also force the plan by using SP query store force plan. But I did it through the graphical user interface. Now let me go ahead and execute that particular store procedure with a different ID, any ID, right? Execute that. And if you go ahead and execute that by using the actual execution plan, include actual execution plan on and execute it, it will create the same kind of execution plan. If you go ahead and see here, if you refresh, it will not create any new execution plan. It uses the same old execution plan, this particular index seek and the key lookup nested loop. Index seek, key lookup, and nested loop. It will go ahead and use that particular force plan. Now I would like to go ahead and change the query store operation mode as read only. So what it will do, it will only read the force plan information. It cannot write any information. Now let me go ahead and clear out my procedure cache. It cleared out my procedure cache. So what it does, I'll go ahead and I will go ahead and execute the store procedure one more time. Now it will go ahead and search in the plan cache. But as I cleared out my plan cache, it won't find any plan cache. So what it does, it will go ahead and check for the query store execution plan, but the query plan is not there in the plan cache. So it will go ahead and create the similar kind of plan like the forced plan, and it will use that. So once I execute that, right, it has created a similar plan, index seek in the key lookup. And when you go ahead and refresh that, it will not create any new execution plan here because number one, we already have a force plan. It will create a similar force plan. And number two is we put the query store in the read only mode. So it will read the information. It will collect the information of how the force plan is, how to force the plan from there, but it will not write any information to it. Let me go ahead and turn off the query store. That's my first demo. Now let's go ahead and see the second demo. How I use the query store in my database upgrade situation. Here we are using wide world importers data warehouse database. First thing I would like to do is free up my procedure cache and then put the database in the read write mode and also apply the similar kind of options that we have enabled in our previous demo for the AdventureWorks database. Let me do that. And next, let me go ahead and um, place the database in our older compatibility mode. So this particular server is 2016 server. So what I will do is I will go ahead and um, let's imagine we have upgraded a database into the 2016 mode, but um, but we have to place the database in the same old compatibility mode from where we got so that we can collect the data by using the query store in the newer environment. Let me go ahead and set the database level compatibility to 2012, and then let's say we already have a store procedure, but I'm just making sure we are creating it again. Let's imagine we already have this stored procedure in our older versions or in our older SQL Server before upgrade. Now I'm going ahead and clearing out my procedure cache and the query store. Now I'll go ahead and execute that particular stored procedure just like the way it used to be in the older versions of SQL Server. Because we enabled the query store in the newer version of SQL Server, I'm going ahead and executing that. So this particular query execution plan is being captured, right? Let's go ahead and see if it already captured. So that database is data wide world importers data warehouse. Go to the programmability, um, sorry, go to the query store, top resource consuming queries. We want to view it in a grid view. And then if you see here, it has captured this information, right? Just like the way it used to execute in the older version of SQL Server. Now what I will do is I'll go ahead and um, now I'll go ahead and change the compatibility mode to 2016. Now I'll execute the same store procedure, same workload again to see the differences. Now I'll go ahead and refresh this. The latest version of um, the latest after the compatibility mode has been changed to the newer version of SQL Server, the plan ID 2 looking like it is working fine, right? It is working better than before. So if you hover your mouse, the execution count is 1 and the average duration is 16 milliseconds. But the older version, when it was in the older version, it is 28 milliseconds, which is like in this situation, right? It is working fine. But what if there might be some situation where this will be reversed? The older version of SQL Server will be run, older version of the query will be running fine, and the newer version of the query might not be running fine. So in that case, you can find the difference between two query plans. You can easily find the regression and you can force the plan. If you think the plan 1 is working fine, you can go ahead and force it. If plan 2 is working fine, the newer version, you can just go ahead and force that plan. Or as it is already being used, you can know the difference between the the older version execution plan as well as newer version. Like if you do not do this baseline, if you do not capture that information, you do not know how your queries were running previously. So if you see the sudden change after the compatibility, you would not know what is causing the problem. So that is the reason we used here during the database upgrades. And there were a couple of situations where I have it has helped me to find the regression and to force the old good plan. That's my second demo. Let me open up my third demo, query store failures. So once we have enabled the force plan, um, you might also see a couple of failures. So let's go ahead and talk about that here. I would like to go ahead and clear up my procedure cache. In this demo, we are using sorry, the wide world import as data warehouse. Let me go ahead and clear out my query store as well as my procedure cache. And in the previous execution plan, right, that the one which we forced, the one which we have seen for the worldwide importers data warehouse, there is this supporting index that we have to create for for that particular query, for that particular store procedure. Let me go ahead and create that supporting index already exist on the table. Okay. So now let me go ahead and execute this particular store procedure by using the actual execution plan on. So this is the execution plan currently. Now what I'll do is I'll go ahead and see top resource consuming queries, refresh, and then see top resource consuming query. Maybe I have to drop this index. I forgot to restore the database to the original version. So let me quickly do that before moving further. Sorry about that. I forgot to restore the database. My I do not want to miss my demo. So let me restore um, my database very quickly. I think I have to. So let me go ahead and uh, databases, kill the connections to this database. Maybe I have to kill this one. So there are connections to this database. So let me go ahead and quickly change that kill database connections. I use this I use this query a lot. I know where to go to collect this particular query. So for 2012 and above, I use this query. I'm sorry, I'm taking a little bit of time to restore my uh, database. I just forgot to do that previously. Okay, so I need to. I think I'm okay now. It is restoring. So meanwhile, let's see this one. It's executing. Okay, the database has been restored. Sorry, I took long time. So let's talk about the failures now. So let me clear out my, if you have already enabled it, I believe we need to enable the query store as well because we wanted to capture, right? So in my database upgrade, I will go ahead and enable this. Okay. And then just to make sure, I create this store procedure. Okay. Now what I'll do is I'll go ahead and clear out my procedure cache and everything, and then I'll go ahead and create this non-clustered index. Right now it is created. So now I'll go ahead and execute this particular store procedure after I creating the supportive index. So once I go ahead and create that, right now it is using index seek. It is using that index that we have created. And if you go ahead and refresh the top resource consuming queries and go to the grid view mode, here it is it created the index seek. It is being used here if you observe here. So what I will do here is I will go ahead and force this particular query. Force, yes. Now why I am forcing this query is query plan is because I would like to go ahead and modify this particular index that has been used. So now what I will do is I will just go ahead and drop that index, but I have forced that query, right? The next time I run the particular store procedure, which is being used, the force plan. Now, did you observe it did not use the force plan because the index that has been used inside the force plan is being dropped. And if you see here, it is showing a different column store index scan instead of index seek because there is no index. We have dropped that one. So how to know our query did not fail? If you see here, the results are working fine. We have the results. Um, but if you go ahead and see, if you go ahead and refresh, right, and then go ahead and see here, I would like to just in case close this one and then this one. And then I would like to go ahead and see queries with the forced plan here to view the queries with the forced plan. Here, if you see this particular store procedure has a forced plan ID of 3. We have forced the plan ID 3, but there is a forced plan failure count which is 1. And the reason for the failure is no index because the index that has been used inside this forced plan index seek, right? This index has been dropped. So there is no index associated with that force plan we have been dropped. So that is the failure reason. Now what we will do is we'll go ahead and recreate that index that we have dropped. Now we have recreated it. So what will happen once we recreate it and once we execute the query, uh, it, once we execute the store procedure, it will go ahead and use that index seek again because we already have this plan as forced. It is easy for the optimizer to go ahead and use that force plan. So now what we'll do is go ahead and um, we'll go ahead and modify the index that we have created by adding another column. The name of the index remains the same, but we are modifying the data, the schema of the index. Now we'll go ahead and rerun the store procedure one more time to see how it will work because we remodified, right? Modified the schema. Execute that one. If you observe here, it looks like it did not use the force plan because here it is showing column store index scan again. Now let's go ahead and see, refresh this one and see the failure count. So here the query ID 3 has been forced with the force plan ID 3, but the force plan failure count is 2. So what is that failure count number 2 mean? It's no plan. There is no plan associated with that particular schema. No matter if the name of the index remains the same, but the schema of the we changed the column of the index. So that is the reason it shows as no plan. So, but if you observe here, there is no plan ID failure count 1 information. There is only updated information. To get all of that information, we need to use other methods, other capture methods by using the extended events. We have the extended events to capture that information as well. That's how the failures and how we capture and look into those failures. Let's talk about the automatic plan correction, where we will be using Azure SQL Database. So let me go ahead and connect to the Azure SQL Database. This is my Azure SQL Database. Adventure works again. So I'm going to set automatic tuning to be turned on. So here we are going to see the how the automatic tuning actually works. So force last good plan to be turned on. So let me execute that. It is taking a while to run. So I place my database in the serverless mode. So the first connection is did not execute it properly, but the second run will be, I hope, hopefully it will run fine. It says timeout error. So let me do that one more time. See the third time it worked. So because I auto paused my database, it took one or two executions for me to connect. So I'm going ahead and running this particular store procedure, the same store procedure that we created for the AdventureWorks database. I'm executing that. Um, I'm executing that, and basically what I did here is I also checked for the database automatic tuning options here. So it has given me all of the information that has been chosen for the last good plan. So we have enabled the force last good plan to be turned on. So if you see the actual state is 1, actual state descending is also 1, is also turned on. And now what I'll do is I'll go ahead and clear off the query store information and the procedure cache. Now let's go ahead and see how the automatic plan correction works. So we are not forcing anything here. We are going to see how it will automatically be forced. So let me go ahead and execute this saves information store procedure. We'll go for 50 times. Now, why we are doing it 50 times is because we are doing the workload. We are creating a workload, right? So let me go ahead and open up my Azure SQL database and then go to the, if you refresh here, you see the query store, top resource consuming queries. You can close here and then go to the grid view mode. So if you see here, you have plan ID 1 that has been created for 50 times. Go 50 meaning we have run the executed that store procedure for 50 times. Now let me go ahead and clear out my procedure cache so that we are forcing the optimizer to create a plan for us. So now what, we did not force any plan by the way. Now create a regression, because for 942, how many did we receive? How many rows? We received so many rows for that, but for this, let's see this one. So first we have run with 942. Now let's run with 707 to create the regression. So let's see how quickly this particular query runs. So this one is taking a little bit of time to create the regression, because this one, how many rows, it is taking a while to run it 10 times. So let's see how many rows it is creating. This one 237K, because there are many rows, so it took some time. So if you go ahead and see here, right, if you refresh here, it automatically went ahead and forced the plan number 3, because plan number 5, right, the latest one, it took the total duration of um, 419. So let me go ahead and close this one. I think this is not the new one, adventure work. So let me go ahead and see this one, refresh. It created the new plan, right? This is a new plan. Now let's go ahead and run the same workload again, 942 workload again, the first workload one more time to see like it will go ahead and compare, right? So let's run this one and let's go ahead and refresh this one, refresh and see whether it will automatically be forced. Did you observe it automatically forced this one because it compared and it thought the plan one is running fine. So if you if you hover your mouse over there, the total duration is 1276 milliseconds. But the older one, the newer one, right, the regressed one is taking like 17,000 milliseconds. So it thought the plan one, the last good plan is plan one, and it has actually forced the plan one. So that's how it will go ahead and automatically force. And the next time the force plan, the next time the query runs, it will use the force plan. And if any case a new plan got created, it will go ahead and compare with the plan number one, plan ID one. And if the newly plan generated plan is better than the plan ID one, it will go ahead and unforce the plan one and force the plan number, newly created plan number. Now, I forgot to show you one more thing over here. So if you wanted to know what is the reason for the forced plan, right? Select star from sysdmdb tuning recommendations will give you the latest information of why it has forced the plan. If you go ahead and run that in AdventureWorks database, it will say there is a forced last good plan, and what is the name? What is the reason for that? The average query CPU time changed from 1.4 milliseconds to this much. So that is the reason the average CPU time has been changed, and that is the reason why it has forced this plan. So you can only see the latest reason um, for the uh, for the reason, like what is the reason for the change of the plan. That is this one. And then let's see our last demo of query store hints. So query store hints, like I said, we will take an example of a store procedure. Again, we are using our AdventureWorks database here, and we wanted to use the Azure SQL Database. So we are trying to create the same exact store procedure just in case, refreshing the store procedure by recreating it. And then let's go ahead and clear out our procedure cache and the query store, clear the query store as well. We already enabled our query store on AdventureWorks database in our previous demo. So let's go ahead and execute this store procedure with two different parameters and see the values and execution plan as well, right? Execute and see their execution plan. So if you see the results, the first execution has created 360k rows. The second execution has given only 385 rows. But if you observe here, anytime a store procedure is created, the first time the store procedure runs is when the execution plan will be created, and the next executions will be using the same execution plan, no matter if it is optimal or not, right? That's how it works. Now, for 300 and how many rows? For 360k rows, it took around um, it did clustered index scan, which is fine, but for the second execution, it only given 385 rows, which also use the clustered index scan. There is no need of using clustered index scan for that particular parameter. So this is a parameter sensitive query. So what we'll do is, for using the query store set hints, all we have to do is we have to find the query ID for this particular store procedure. So how to find that? By giving the by giving the query text, by using the like parameter, by using the this particular query, you can find the ID, query ID, which is 1. Now what we have to do is we have to use the SP query store set query hints, set hints query ID, give the query ID, which is 1, and use the recompile. So what will happen is the next time the query runs, it will go ahead and recompile, and it will recreate the execution plan based upon your parameter. I'm going ahead and executing that, and next time you run the execution plan, the same store procedures with the same parameter one more time. Now we will see the difference over here. Did you observe as we are recompiling it, the next time it runs with this parameter, it recompiled and it created the execution plan based upon that parameter, which is which is really cool. Not only that, we can also find out what type of query hints were enabled currently by using this particular query. So the query hint ID is 1, the query ID is 1, and the query hint text is recompile. That is what we are using for this particular query. Now, not only the recompile, we also can use other query hints as well, right? The query store hints. So let's use the max top one here. So let's say for the same query ID one, I would like to use value option max top one. So let me execute that. Oh, um, and then go ahead and execute the same stored procedure by clearing out the cache. And then if you observe here, we removed the we override the recompile by using the max top one. So if you are executing a query hint on already existed query hint, it will go ahead and override it. So it is not using the recompile anymore, but it is going ahead and using, once you click on select operator, go to properties and see here, it is using max top set to 1. Even for the second one, it is going ahead and using the max top set to 1 feature, max top set to 1. Now, instead of only using maxstop or recompile, let me go ahead and use the similar two of them in the same store procedure. So for the query ID one, I would like to go ahead and use multiple query hints, query store set hints, recompile and maxstop one. So what will happen if I execute that? It will overwrite the existing one. And if I go ahead and execute right now, now it will go ahead and use the both the recompile. If you observe here, it recompiled, as well as it will go ahead and use max stop set to 1. Even here it will go ahead and use the max stop set to 1. Now if I wanted to remove, right, remove all of the query hints that I have been forced on a query ID, just use execute sp query store clear hints will clear out the query store hints. Now, if you go ahead and see what all are the query hints currently running, you will not find anything because you have deleted the query hints that you have already enabled on this particular query ID. You have cleared that. Again, for a complete list of the supported query hints, this article has provided the list of query store hints that are enabled and active. I mean, that are supported by the Azure SQL Database, which is in the preview mode right now. So that's all for my demo. Let me go ahead back to my um, slides. To use the query store, there are certain queries that have been uploaded to the GitHub by Channel Advisor, which are completely free, which is known as QDS Toolbox, which is query store toolbox, which is completely free. You have all of the query store views and the other queries that you can go ahead and run on your query store enabled database to get all the useful information that you need. And to learn more, there are best practices that you have to make sure you know. So I'm providing the Microsoft Docs down below here. You can go ahead and see all the best practices. Make sure before you enable all of these options, you know what they mean and how it will be useful uh, how it will be useful for your workload. And these are the resources, Microsoft Docs, I followed for preparing this presentation. And I have used pixels.com for using these beautiful pictures in my presentation. And I have been blogging about Query Store on my blog as well, which is dbanuggets.com. I started a couple of like series of blog posts only related to the Query Store. So if you would like to learn more, there is couple of more points and then couple of more information I have added. Basically, it's an extension of this particular presentation. If you would like to go ahead and learn more. And I would like to thank Gregor and Richard one more time for giving me this wonderful opportunity to be able to present for Festive Tech Calendar 2021. I'm so honored to be here and also hopefully in the coming years. Once again, thank you so much and Merry Christmas to one and all. Thank you.